Right. In this section, we're going to continue talking about conic sections, and now we're going to talk about ellipses. Okay, so remember, if we have conic, they're called conic sections because we have these two cones together, and an ellipse is a plane intersecting one of the cones at an angle. Right? If it was perfectly horizontal, then we'd have a circle, which is really just a special case of an ellipse, right? But here we have an ellipse. So that's what we're going to talk about today. And if we were going to draw an ellipse, here's how we do it. We take a piece of string and get two thumbtacks and put them down at 2 points. Each of these is called a focus point, and together they are called foci. Okay, so we have two foci, two thumbtacks. Remember, for a circle, we just had one. We have two thumbtacks and this string, so it's a fixed length, and a pencil, and we would pull the string around. So everywhere on this ellipse, this string would sort of demarcate where we would draw it. So here's some terminology for ellipses. The longer axis is called the major axis. And along the major axis is where we have our two focus points, or foci. Right? Here's our center. And we call this the minor axis, the shorter axis. And on the major axis, the intersection of the axis with the ellipse are called the vertices or vertex. Each of these points is called a vertex, and together they're called vertices. And each of these points on the minor axis are called the covertex, and together they're the covertices. Okay? So we've got more points than usual, right? With the circle, we just had the center. Here we've got a bunch of points. We have the center, we have the two foci, we have the two vertices, and we have the two covertices. So one thing to notice is that the foci are always going to be along the major axis. Whichever axis is longer, that's the axis where the foci are going to be along. So the major axis sometimes could be along the y-axis. In this course, we are only going to worry about if the major and minor axes are like parallel or perpendicular to the x and y axis on the regular plane. We're going to shift the ellipses around, but we're not going to like rotate them, right? So you can do that. We're not going to worry about it. We are just going to take our ellipses where the major and minor axes are like the same directions as the x and y axis and shift it, but not rotate it at all. All right, so here is what the equation for an ellipse looks like. We have an x squared and a y squared term. We have a squared and b squared. So a is going to be the distance from the center to a vertex. Okay, so this distance here is a, and this distance here would be b. Okay, so remember, in a circle, those are the same, but in an ellipse, they are not. And we're always going to have it equal to 1. Okay, so we'll talk about this equation more. So let's think geometrically a little bit more. So here, again, we have our major axis is along the x-axis, our minor axis is along the y. We're centered here at the origin to start with, okay? And here are our two foci, okay? They are c units from the center, okay? So here's the first thing we're kind of setting the stage here. So an A0 and negative A0 are our two vertices, okay, because those are along the major axis where the ellipse crosses the major axis. So here's A and negative A, and here's C and negative C. So here's the first thing just to notice. If A0 is a vertex of the ellipse, the distance from negative C to A, so this distance, is A minus negative C, or A plus C. Okay, so the distance from A to this foci, or focus point, is A plus C. So the distance from A to negative C, and from A to this C, is 2A. Okay, you could also think of that as A minus c, and negative. So think about this equation. Okay, a plus c plus a minus c is 2a. We're going to use that on the next slide. Now let's think about d1. So d1 is the distance from this focus point to the ellipse, and d2 is the distance from this focus point to the ellipse. Okay, so here we have just a generic xy point on the ellipse. Okay, and we're going to call this d1, and we're going to call this d2. What do we know? We know that d1 plus d2 is constant. That's the definition of an ellipse, right? These x and y values are going to change, but d1 plus d2 will always be the same because this is like a string. It's a fixed distance. Okay, that's the definition of an ellipse. All right, this next slide is going to surprise you. Okay, this is how we can derive the equation of an ellipse. You are not going to have to do this. I just put it on here in case you're interested. Okay, so I'm not going to take time and go through this. If you're interested, you can definitely follow this math. Okay, so I would recommend being curious and pausing this video and just looking through this. This is also in your textbook if you don't want to look it on the video. Okay, this is the derivation of this equation at the bottom, x squared over a squared plus y squared over b squared equals 1. Okay, we start with the distance formula for d1 and d2, and then it goes through it. Okay, there's a bunch of algebra. You can follow each of these steps. You know all of the math you need to know to follow this derivation. If you're not interested, just move right along. Okay, don't get stressed out by this. You're never going to have to recreate it. But if you're curious where this equation comes from, now you know. Okay? All right, so here we are. We know here are the standard forms of the equation of an ellipse that's centered at the origin. Okay, so we've got two situations. One is that the major axis is along the x-axis, and the other is that the major axis is along the y-axis. Okay, so notice the focus points, the foci, are always along the major axis. So in this case, they're along the x-axis, and in this case, they're along the y-axis. Okay, and what's the difference between these two equations? In this case, a squared is under x, and in this case, a squared is under y. Okay, really, these are the same equations. What it means is, if you have this form of the equation, whichever number, a is always bigger than b. Okay, so whichever x or y has the bigger number underneath it, that's the one that's your major axis. Okay, in this case, a is bigger, it's under y is the major axis. And the focus points are going to be along the y-axis. In this case, a, the bigger number, is under x squared. So x is the major axis, and the focus points are along the x-axis. So maybe you're curious because we have a is this distance, and b is this distance, and c is the distance from the origin to the focus points. And I don't see any c in our equation here. Right? There's no c. There's like a separate equation we need to know to be able to find our focus points. And here it is. C squared equals a squared minus b squared. Okay? So this is like a separate equation you need to know to be able to properly interpret ellipses. C squared equals a squared minus b squared. All right. Let's do an example. We're just going to do a bunch of examples. Okay, we're starting. So what is the standard form equation of the ellipse that has vertices at plus or minus 8, 0, and foci at plus or minus 5, 0? Well, let's just think for a minute. What do we know already? The vertices are at plus or minus 8, 0, which is going to be along the x-axis, right? And the foci are along the x-axis as well. So we know that the equation is going to have this form, right? Our major axis is x, okay? Because the vertices are along the x-axis. So our equation is going to have this form. What can we figure out? Well, we know the vertices are here, so we know what a is, right? The a is 8, and a squared is 64. So we know that's a part. We know the foci. are plus or minus 5 and 0. So c is 5, and we know that c squared equals 25. Okay, so we know a, we know c. What do we need to still know? We need to know what b squared is. So we use this formula, c squared equals a squared minus b squared. We know c squared, we know a squared. We solve for b squared, it's 39. Okay, so our final form of your equation is x squared over 64 plus y squared over 39 equals 1. We just needed to know a squared and b squared. We used c squared, but it doesn't show up in our equation anywhere. All right, the next thing is, okay, that's everything at the origin. What if we want to shift our equation around? Okay, it's going to be just like the translations we've already thought about. If our center is at HK, here's our equation if the major axis is the x. Here's our equation if the major axis is the y. The only difference is which term the bigger number is under. Okay, and our c is going to be, c units from wherever our center is. Okay. All right, let's do some examples. We're going to work through a bunch of examples now. All right, what is the standard form equation of an ellipse that has vertices at these 2 points and foci at these 2 points? You can do these things algebraically, and if you're really good at just keeping track of things in your head, go for it. I think it's much easier to just graph these things out to get a sense of what's going on. So let's take a look. Look, I have graph paper, so everything looks better than it did for circles. Okay, so the vertices are at -2, -8. So 1, 2, 3, 4, 5, 6, 7, 8. So here's one vertex. And the other vertex is at -2, 2. All right, so those are our vertices. So we know this is our major axis, right, along the y-axis. And our foci are at -2, -7. 1, 2, 3, 4, 5, 6, 7. And -2, 1. That's what we know so far. So let's think about this. What's the form of our equation going to be? It's going to be x minus h squared and y minus k squared is going to equal 1. And where is the a? Which term is going to have the a? The bigger term is going to be under y, right? Because we know that our y-axis is our major axis. This is going to be a squared and this will be b squared. Okay, well, what can we determine from this so far? We could find the center, right? The center is going to be halfway between these vertices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a difference of 10 between them. So 1, 2, 3, 4, 5. Here is the center, right? 5 units. Whoops. Sure. Hopefully that's somebody I know. Okay. So halfway between these 2 vertices. Okay, there's our center. So let's see, what is the center? That looks like it's at -2, -3. So we can already start filling some things in. This is going to be at x plus 2 squared and y minus 3. So this will be y plus 3 squared. Do we know either a or b yet? We do know a, right? A is 5. A is the distance between the center to the vertex. So this is going to be 5 squared, and this is going to be b squared. So again, we didn't really need this drawing, but for me, keeping track of what to subtract and divide by 2 and things, it gets kind of complicated. So it's much easier for me to start sketching this ellipse before I start filling things in. Okay, so we know a squared. We want to find b squared. Do we know what's c? C is the distance from the center to the foci, and that distance is 4. So we know that c is 4, and we know that c squared equals a squared minus b squared. So let's see, 16 is going to equal 25 minus b squared. So we can solve that. B squared equals 25 minus 16, which is 9. So B is 3. Perfect. And that's what we wanted to know. So now we know our equation. X plus 2 squared over 9 plus y plus 3 squared over 25 equals 1. Okay. And let's just finish graphing this for fun. We know that B is 3, so we're just going to go 3 units, 1, 2, 3, in either direction from our center. 1, 2, 3. And now we could kind of connect the dots to make our ellipse. And it's going to look kind of wobbly, but trying our best. So there's our ellipse. Okay? Okay, so let's do another example. Let's do example 3. All right, graph an ellipse centered at the origin. So graph the ellipse given by this equation. Identify and label the center, vertices, co-vertices, and foci. All right. Well, like they said, we can see that it's centered at the origin, and we can see the major axis is going to be y, because this is the bigger number. So let's get going here. Let's 2, 3, 4, 5, 6. Guess I don't really need to do that since I have graph paper. All right. So what's this going to look like? We'll go 5 units along the y-axis. So here's our center. And we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Either way away from the center. And then our co-vertices. Okay. I think my husband's trying to do something on our computer at home. We'll just have to wait. Our co-vertice is going to be 3 units away, right? Okay. 3 units in either direction from the origin, from the center. And there we go. So here's the vertices, 0, 5, 0, negative 5, and 3, 0, negative 3, 0. We could even connect these. And the only thing we still need to find is the foci. Right? The foci we know we're going to be along the y-axis, but we need to find where they are. So we know that c squared equals a squared minus b squared. So it's going to be 25 minus 9, right? A squared minus b squared, which is 16. So C, our foci are going to be 4 units, either direction from the center. So they're going to be at 0, 4, and at 0, negative 4. Okay? All right, let's look at another example. What about this one? Graph the ellipse given by this equation. Can you see that? 4x squared plus 25y squared equals 100. That is not in the form that we can tell much from. All right? We have 4x squared plus 25y squared equals 100. Well, what do we need? We need this to be 1. So let's divide everything by 100. Okay. So what can how can we simplify this? Well, that 4 goes into that once and that 25. 25 goes into that once and that 4 times, and this becomes 1. So that simplified nicely, almost as if it was created for an algebra class. We get x squared over 25 plus y squared over 4 equals 1. Oh, well, that looks like the form we need. Let's see, our x-axis is going to be the major axis. This is bigger. Our y-axis is minor. And let's graph this. So our center, we can see it's centered at the origin, right? And we can go 5 units in either direction, 1, 2, 3, 4, 5, along the x-axis. there are vertices, and we can go 2 units along the y-axis. And now we just need to find our foci. Look what a bad job I did drawing that line. Not good. All right, we know c squared equals a squared minus b squared. And our a squared is 25. And our b squared is 4. So c squared equals 21. So c is the square root of 21. So we'll go square root of 21 units along either direction. So that's going to be like between 4 and 5, like somewhere like here. I don't know. And we could label that. It's going to be square root of 21, 0, and negative square root of 21, 0. And this would be negative 5, 0, 5, 0, 0, 2, 0, negative 2. And we could connect our points in an ellipsis looking thing. Yeah? So sometimes we need to do a little work on the equation. And that might have an ominous sound to it because sometimes we're going to have to do a lot of work on the equation. Let's look at the next example. Example 5. Graph this equation. Oops. All right, this is a nice form. We can look pretty easily and we can see the center is at negative 2, 5. And we can see, you know, that the major axis is going to be y. Minor axis will be x. We can see our a is going to be 3 and our b is going to be 2, right? Because those are both nice, perfect squares. All right, so let's just do it. Let's think for a minute. If our center is here, negative 2, 5, so well, I guess I did that wrong. All right, so negative 2, 1, 2, 3, 4, 5. Here's our center. Our major axis is along the y-axis, and it's a distance of 3. So we'll go 3 units up and 3 units down. And our minor axis is x. We'll go 2 units either direction along the x-axis, or in the x direction, I guess. And let's see, we still don't know our c squared, or what our c is. So c squared equals a squared minus b squared. So that's going to be 9 minus 4. So c squared equals 5, and c is the square root of 5. So that's going to be like a little bit bigger than 2 along the major axis. So like here and here. And we could label all those if we wanted to. Let's not take the time. I bet you can do that, right? The math gets like a little bit, you just have to think through it, right? If this is negative 2, 5, then this is going to be negative 2, 8, right? It's going to be 5 plus however many units we went up. And what would be this focus? Negative 2, 5 plus square root of 5, right? For that focus, and this would be 5 minus square root of 5. I said I wasn't going to do it, and here I am just doing it all. This co-vertex is 0, 5, and this one is negative 7, 5. Right? And we can keep going. All right. Let's do another example. Example 6. All right, the good news is this is as bad as they get, okay? But we can do it. It's just going to require us to complete the square like we did with circles. All right, so when we have something in this form, we have an x squared term and a y squared term. We know that this is going to be some kind of conic section. We don't know what kind. In this case, it's in the ellipse section, so it's probably going to be an ellipse. But later on, it won't matter. We're going to do the same thing every time. We did just like we did for circles. We're going to write this. We're going to clump all the x terms together and clump all the y terms together and move the constant to the other side. All right, here is the tricky part. Okay, we're going to complete these squares, but here's what we have to notice. Before we can complete the square, the coefficient of x squared must be 1. Okay, so can't forget this step. We're going to factor whatever the coefficient of x squared is out of that term. And we're going to factor 9 out of these terms, the y terms. Yeah? We factor out of the x terms whatever the x coefficient is, and we factor out of the y terms whatever the y coefficient is. And now we complete the square. So let's see, negative 10 divided by 2 is negative 5. Squared is 25. So I'm going to add 25. Here's a trick question. Did I really add 25? No, I really added 25 times 4. I really added 100 to this side. So what do we have to add to the other side? 100. Don't forget to multiply by this number here, right? Okay, so now we complete the square for y. 4 divided by 2 is 2. Squared is 4. So I add 4. But I didn't really add 4. I really added 36, right? So I add 36 to this side as well. All right, now I rewrite this as 4x minus 5 squared plus 9y plus 2 squared equals 36. This is looking good. This is a lot closer to what we need. What's the problem? We need this to be 1. So, cool, let's divide everything by 36. And it just so happens that these are going to simplify. Right? We can write this as x minus 5 squared over 9 plus y plus 2 squared over 4, right? The 9 and the 36, both divide by 9, equals 1. Dun, da, da, da. We did it. This is a nice equation of an ellipse. We can look at this pretty easily. We can find that the center is at 5, negative 2. The major axis is going to be x because this is a bigger number. So let's do that. 1, 2, 3, 4, 5, negative 2. Here's the center. Let's graph this. Our major axis is 9, so we're going to go 3 units along the x-axis. 1, 2, 3, 1, 2, 3. Our minor axis is y. We're going to go 2 units up and 2 units down. And now we're going to find c. C squared equals 9 minus 4, right? A squared minus b squared, which is 5. So c is the square root of 5. So a little bit more than 2 units from the center in either direction there. And there we go. And they said to identify and label. I think you can do that, right? This is the hard part. So, I mean, once we got here, this was just like the problems we've been doing. No big deal. Completing the square was new. Okay? For all of the conic sections we're doing, we're going to have to complete the square. So don't run away from this. You can figure it out. It's not that bad. Okay? You clump all the x terms, all the y terms, bring the constant over here, factor out the x and y coefficients, complete the square, and add this coefficient times 25 over here, this coefficient times 4 over here. Right? This is a perfect square. Now we make this 1 by dividing by 36. Right? Simplify, and there we go. Okay? All right, one last thing we're going to talk about is applications of this. All right, so let's just use this image here instead of going back. This actually is really important for acoustical engineering, okay? If you have, I don't know if you've ever been in like a specially designed like whisper space or something, where if you have 2 people standing at the foci, if they whisper, and it's like good acoustical like materials, that it bounces off wherever, all of the sound waves, wherever they go, bounce off and go exactly back to the other focus point. So the sound from here to here is like very amplified, okay? So That's what they say. The statuary hall in the Capitol building in Washington, D.C. is a whisper chamber. Its dimensions are 46 feet wide by 96 feet long. What is the standard form of the equation of the ellipse representing the outline of the room? Okay. So let's think about this. What do we know? We have an ellipse. And here's the center, let's say. And we know this distance is 23, right? Half of 46. And this distance is, what is that? 48? 48. Okay. So let's think. We can just assume that this is like the center, right? So our equation is going to be like x squared plus y squared equals 1 over, let's see, in this case, our x-axis will be our major axis. And we know our a value is 48. So this is going to be 48 squared. And our minor axis, this is going to be 23 squared. Voila, there's our equation. And now they ask, okay, if two senators standing at the foci of this room can hear each other whisper, I feel like there should be some political joke here. I don't know. Think of one yourself. We have two senators whispering. What are they whispering? I don't know. All right, how far apart are they? So really, we want to know what is c, right? Well, c squared equals 48 squared minus 23 squared. So c is the square root of that, which I'm going to cheat and just look at what they say it is. 42. C is plus or minus 42. Whoops, not square root, just 42. Okay, if we went through the math, whatever. All right, so this distance is 42, so the two senators are 84 feet away from each other. Okay? But the idea being that this is kind of a cool idea, and it actually is used, and this is another place this is very important, is in optic stuff. Okay, so these two focus points for acoustics and optics are important. Parabolas also. We'll talk about parabolas later. All right, so we've got our two focus points. We could find an equation of this ellipse. That was kind of a lot. You'll get lots of practice. You can ask me questions. Good luck. Have fun dealing with ellipses.